So the next type of trigonometric expressions that we come across are the quadratic type expressions. For example, so if you have a trigonometric expression which is sine square theta minus 5 sine theta plus 6 is equal to my f of theta. So f of theta is equal to sine square theta minus 5 sine theta plus 6. And you're asked to find the range of this expression. So this is an example of the trigonometric expressions of the type quadratic. So how do we analyze this? We analyze this expression using the method of completion of squares. Here also the problem is that sine square theta and sine theta are depending on each other. So there is, as theta varies, this term varies and this term also changes. As these two changes depending on each other, so we need to analyze this expression very carefully. So now how do I do this? I'll try to bring the variation into a single term by using the method of completion of squares. So method of completion of squares is nothing but you have sine square theta. So we use the formula a plus b whole square is equal to a square plus 2ab plus b square, and a minus b whole square is equal to a square minus 2ab plus b square. We use these two formulas to complete the square. So you have sine square theta already, something like a square. So you have a minus here. So this term, I'll try to write it as minus 2ab. So minus 2 times sine theta times, so minus 5 theta can be written as minus 2 times sine theta times 5 by 2, right? So a square minus 2ab. So I have converted these two terms into a square minus 2ab. Now if I have to have a minus b whole square, so I need a b square term. So what I do is I'll add and subtract that b square term. So plus 5 by 2 whole square minus 5 by 2 whole square plus 6. I've added this and subtracted this, so there is no effective difference in the expression. So now what is the thing that I get out of this? So now if I take the first three terms, so I can write this as sine theta minus 5 by 2 whole square, right? Sine theta minus 5 by 2 whole square minus 25 by 4 plus 6. So you get minus 1 by 4. Minus 25 by 4 plus 6 is minus 1 by 4. So this expression f of theta is equal to sine theta minus 5 by 2 whole square minus 1 by 4. Now, this expression is very easy to analyze because there is only one thing that is changing sine theta. So let us start with sine theta and go further. So sine theta lies between minus 1 and plus 1. So sine theta minus 5 by 2 lies between minus 1 minus 5 by 2 and 1 minus 5 by 2. That means sine theta minus 5 by 2 lies between minus 7 by 2 and minus 3 by 2. Now if you square these numbers, so if you have a real number line minus 7 by 2 and minus 3 by 2, so this expression lies between minus 7 by 2 and minus 3 by 2. So if you square this expression, where does this go? All the numbers go to the positive side. So this implies sine theta minus 5 by 2 whole square lies between. So if you square minus 3 by 2, it becomes 9 by 4. This becomes 49 by 4. So lies between 9 by 4 and 49 by 4. So this expression lies between 9 by 4 and 49 by 4. And if you subtract a 1 by 4, this belongs to, if you subtract a 1 by 4 from this, so you need to subtract 1 by 4 from this side as well as this side. So you get 8 by 4, which is 2, and you get 48 by 4, which is 12. That means this expression, which is equal to this expression, lies between close to and 12. So what is the range of this expression? Minimum value is 2, the maximum value is 12. So this is how we deal with trigonometric expressions of the type quadratic. So next, in the same type of questions, let us take f of theta is equal to cot square theta plus 4 cosecant theta plus 5. So you're asked to find the maximum and minimum value of this expression. So now this expression contains cot and cosecant. You have two different trigonometric ratios. So even if you want to use the method of completion of squares, you need to have the same ratio here. So first our aim will be to convert this trigonometric expression into an expression of a single ratio. So we can do that in this question using the concept of identities. We know that cot square theta is equal to cosecant square theta minus 1, right? So if I substitute in the place of cot square theta, cosecant square theta minus 1, so you get the expression completely in terms of cosecant theta. So this becomes cosecant square theta plus 4 cosecant theta plus 4, right? Minus 1 plus 5 is 4. So this is equal to, now if this is an expression completely in terms of cosecant and this is of the form quadratic, so I'll try to complete the square. So we have cosecant square theta plus 2 times cosecant theta times 2 plus 4 is nothing but 2 square. So you already have a complete square, which is equal to cosecant theta plus 2 whole square. So this expression has got converted into cosecant theta plus 2 whole square. Now what we observe is the values of cosecant theta plus 2 in the starting, and then we'll square it and see where the numbers lie. So we know that cosecant theta belongs to either minus infinity to minus 1 or 1 comma infinity. So cosecant theta plus 2 belongs to, so minus infinity plus 2 is minus infinity, minus 1 plus 2 is plus 1, or 1 plus 2 is 3 and infinity plus 2 is infinity. That means cosecant theta plus 2 will either lie between minus infinity to 1 or 3 to infinity. That is, if you take the real number line, so you have 1 and 3, so it either lies here or 3 to infinity. So you have a 0 somewhere here. So all the negative numbers are covered and 0 to 1 is also covered. So now if you square this term, cosecant theta plus 2 whole square belongs to, so obviously all the negative numbers are covered. So if you square all the negative numbers, you get all positive numbers. And 0 to 1, if you square it, you also get all positive numbers. 3 to infinity, if you square it, you get all positive numbers. So the effective range is nothing but all positive numbers 0 to infinity. That means the minimum value of this expression is 0 and the maximum value of this expression is infinity. So here what did we learn? So if the given expression is in terms of two trigonometric ratios, so you just need to convert them into one trigonometric ratio using the concept of identities.